but I'll be on it always, always.
Hi, welcome back to the Pink Chemist. So today we are going over hydrocarbons. Now, before we start, I do want to make sure and give you time, if you haven't already, to grab your notebook so that you can take extensive notes. If you are in my class, you should have your composition notebook alongside of your unit packet as we go through this lesson. Now, it's quite a bit of examples that we have to get through. So let's go ahead and hop right into it. Now, before we start doing examples, I do want to start us off with a few essential notes, okay? Now, what you need to know is that there are three types of organic bonds that's created in a hydrocarbon. So there's three types. And the first type that you should know about is what we call an alkane. When it comes to alkane, they are identified by single bonds. If you have a single bond, okay, your single bond will literally look just like a line, like I just drew right here, okay? That is what a single bond looks like, okay? The second type is called an alkene, all right? Your alkene is represented by double bonds. So your double bonds, it looks like an equal sign, but it is represented by two lines, okay? And then your third type is what we call an alkyne, and that is when you have a triple bond, and the triple bond is represented by three lines, okay? This piece of information is important because when you have these types of bonds, there are some things that you want to know. Now, when you have an alkane or a single bond, it is represented by the suffix ane, okay? So ane is the suffix for a single bond. The suffix for a double bond is ene, okay? And then the suffix for your triple bond is yne, okay? Now I am going to make a note. Let me try to make a note somewhere. So your suffix for your single bond is ane. Your suffix for your double bond is ene. And your suffix for your triple bond is yne. Okay? Let me, because I know some people, it may be hard for you to follow. So I do want to box so you can see the difference. All right, so that's for your single bond. This is for your double bond. And this is for your triple bond. Okay, just in case you're confused. So your suffix is what's going to go at the end of your name for your hydrocarbon. Now, there is one more thing that I would like to add here for our notes before we begin. And what I want to add is when we are identifying our number of hydrogens, actually, as a matter of fact, when we get there, I will write this down when we get to that example. Okay, so this is very important. I hope you all got that. Let's go ahead and get into doing our first example. Now, as we go into doing our first example, I do want you to also know that there are a few ways that you can see a hydrocarbon being represented. And so the first way that I want to identify is that they may give you the formula, okay? The question may start with the formula. So the formula, the example we're going to use today is CH4. CH4. Now, if they give you the formula, that means that they want you to identify the name of that hydrocarbon. Now, at the bottom left-hand corner, I do have a step, 3 steps to help us to identify this. And so let's make sure we're referencing that when necessary. And on the right-hand corner, I do have the prefixes that we would need in order to identify the name of the hydrocarbon. Okay. So first things first, if they give me the formula, okay, I am going to look and count the number of carbon atoms and write the prefix for that number. Now, what I want you to see is that for carbon, you see that C right here, the C right here, okay? When I look at the subscript is the number that's next to that element symbol. So in this case, carbon does not have a subscript. So that means that carbon is just 1. So since carbon is just 1, I'm going to go down to look at my prefixes for carbon. And my prefixes for carbon, which is 1, is meth. So since that's the prefix for carbon, I am going to write the prefix meth, okay? Because I only have 1 carbon. Next, I am going to go and look at my hydrogens. Now, this is important because I now have to identify what is going to be my suffix. In order to identify your suffix, you want to be able to identify the number of bonds that you have for that formula. Now, in order to identify the number of bonds, you're going to have to use, in this instance, what we call formulas. So for your hydrogen formulas, you're going to use 2n plus 2. If you use this formula, that means you have a single bond, and you're going to use the suffix ane. Okay? If you use 2n, okay, that means you have a double bond, and you're going to use the suffix ene. And if you use the formula 2n minus 2, that means you have a triple bond, and you're going to use the suffix yne. Now, I do want to make a note that n represents your number of carbons, of carbon atoms. Actually, let me do that a little bit better so you all are not confused. So your number of N's represents your number of carbon atoms. Now, please bear with me. I know some of us know how to follow by just listening, but then there's those of us that need to see it written out. So I want to make sure that I am meeting everybody with what their needs are, because I remember being in school and being overwhelmed with how much information it is in chemistry and trying to keep up with everything. Okay, so your N represents your number of carbons. Whichever formula that you use that identify the number of hydrogen atoms that you have in that formula is going to identify which bond and which suffix you're going to use. So in this case, I see that I have 4 hydrogens. So now I want to see which formula am I going to use that's going to give me 4 hydrogens so that I can identify which bond is it that I'm going to use. So let me see here. I am going to go ahead, and it's going to be more so like a plug and chug. So I got 2N, and I've already said that that the N represents the number of hydrogens, and we've already identified that we have 1 carbon atom. And so I plug in, so I got 2 times 1, which is 2, plus 2, and that gives me 4. So this formula right here is the formula that gives me 4 hydrogens. The 4 hydrogens that I see right here. Okay? So since this formula identifies the number of hydrogens that I have in this formula, that means that I have a single bond. And since I have a single bond, my suffix is going to be ANE. So the name of my formula is methane. So the name is methane. All right. Now I broke that down as much as I can so that as detailed as possible so that you're able to follow, because there are a lot of rules depending on the way that they present the hydrocarbon. So this way was if they gave you the formula. So the next way that they can present a hydrocarbon is they can actually give you the name of the hydrocarbon. So if they give you the name, so I'm going to write name. So if they give you the name of the hydrocarbon, so let's use, for instance, in this case, let's go with butene. Right? So they gave us the name. And when they give us the name, that means that they want us to write the formula. Okay? So what we're going to do is, the first thing is we want to look at the prefix. So in this instance, we kind of want to work backwards. They told us to identify the number of carbons at the bottom, but in this case, when it's the name, they want us to look at the prefix first. So when I look at the prefix first, the prefix is but. And when I look at my prefix chart, I see that but means that I have 4 carbon atoms. So if I got 4 carbon atoms, what I'm going to go ahead and do is I'm going to write C for my symbol for carbon, and I'm going to write the subscript 4. Okay? Because my prefix lets me know that I have 4 carbon atoms. All right? And then once I identify my number of carbon atoms, now I want to identify my number of hydrogens, okay? Because in a hydrocarbon, you're going to have a carbon atom and a hydrogen atom. This is very, very important. You're going to have a carbon atom and a hydrogen atom. Get it? Hydrocarbon? It's in the name. Okay, so now what I have to do is identify the number of hydrogens that I have. And I identify the number of hydrogens by looking at the suffix. And in this case, my suffix is ENE. ENE. Okay. Now I'm going to go ahead and write on the side, because some of us, if we haven't looked back at our notes, because we ain't taking it, I got you. All right. So if I had a single bond, my suffix for my single bond will be ANE. Okay. My suffix for my double bond will be ENE. And then my suffix for my triple bond will be, and let me actually draw the bonds, because you know what, that I'm sure that helps. My triple bond will be YNE. All right. Now, here is the thing. I'm looking, and now I see that ENE is a double bond. If ENE is a double bond, that means that I am going to use the formula 2N. Remember, on the last slide, we already wrote this down, so that's why it's important that you write down all of the information that I'm writing down, because it does come back up. All right? So the formula that I use to find my number of hydrogens for my double bond is 2N. And remember that N represents my number of carbons. So now I am going to plug in 2, and I see that I have 4 carbons. So 2 times 4 is 8. So that means that I have 8 hydrogens. All right. And so my formula for butene is C4H8. And boom shakalaka, I'm done with writing the formula. Okay. Okay. Now the next type of hydrocarbon, or the way that it can be illustrated that they will give you, is that they will provide you with the structural diagram. And in short, that's just the drawing. Okay. Now, what that drawing will look like, you can have, it looks like this. Okay. So this will be a drawing, considerably a drawing. All right. Now, if they give you the structural diagram, you don't have to do as much as what we've done in the last two examples. And that's simply because if you look, you can see the bond that they gave us. So we don't have to actually use the formula. I can look and see here from this drawing that I have a triple bond. Now, true enough, I do see that I have single bonds, but me identifying the site of a triple bond lets me know that this diagram has a triple bond. So now that's important. So the first thing that you're going to do, if they give me the drawing, that means they want me to write the name. Okay. So the first thing that I'm going to do is count my number of carbons. So I see that I have 1, 2. I see that I have 2 C's, which means that I have 2 carbons. If I have 2 carbons, that means that my prefix for 2 carbons is F. So I am going to write F. All right. So that's the prefix for 2 carbons. All right. And now that I see that I gotta write my suffix in this instance, and I see that I got a triple bond, that lets me know, and I'm going to write it over here again so y'all can see it, that the suffix, because this is important, the suffix for A and E is single, E and E double, and Y and E triple. Okay, so now that I see that I got a triple bond, I'm going to look and see that my suffix for my triple bond is YNE. Now, I would think that I'm done, but if we look at our third step, it tells us if we have a double or triple bond at the location number. And this step is very important when it comes to structural diagrams. You would notice that we did not write the location number when they asked for us to write the name or when they gave us the formula. The location number being identified is important, and it goes to when they are giving us the structural diagram. This is very important, and I think this is sometimes where people make mistakes. And that's fine because we're all learning, but I want to make sure that you understand that this is very key. So please pay attention when it comes to this. All right. Now, in the structural diagram, in order to identify the location number, you want to count how the shortest way that it's going to take you to get to that triple bond. So if I start from the right, I see that it's 1, 2. It takes me 2 hydrocarbons to get to the triple bond. If I start from the opposite side of that triple bond, I see that it takes me 1, 2. So in this instance, since both sides takes me 2, I'm going to write the location number 2 with a little dash to let me know that location number that my triple bond is located between the 2. Okay? I hope you follow me with that. And I'm pretty sure, because if it was me, I think I would be kind of confused. So I'm going to give you another example. Okay? I'm going to give you one more structural diagram example to help with this. Okay? So should I do it on a, no, I'm gonna keep it on this one. Okay. I'll give you another one. So let's do, okay. Now, as I'm writing this out, okay, I want you, actually, I want to do a double bond, not triple bond. Sorry, just pausing really quickly. Take this as an opportunity to take a little break as I write this out. Okay, so now that I have this second example written out, and yes, I like to have my stuff color coded because this could be a lot, okay? All right, so now the first step is for us to count the number of carbon atoms. So when we count our number of carbon atoms, we got 1, 2, 3, 4, 5, 6, 7. So we see that we have 6 carbons in this structural diagram. The prefix for 6 carbon atoms is pent. Okay, it is pent. No, it is not pent. What? Because I obviously can't read. All right. So, and I'm glad that actually happened because I feel like that sometimes happen. Like that's a mistake. That obviously says 5 carbon atoms, and obviously you know that when you're looking at the chart that 6 carbon atoms says hex. So just please make sure you pay attention because even though you know it, it is very easy to make that kind of a mistake. Okay. And so when your teacher is checking or when you're on a test, they can't get in your head to say, oh, you made a mistake. So please make sure that you pay attention. Okay. So it is actually hex, all right, for our 6 carbon atoms. That's the prefix. Now I want to identify the suffix. The suffix is based off of the bond. Okay. When I look at this structural diagram, I clearly can see that I have a double bond right here. All right. When I look at my suffix for double bond, I see that my suffix for double bond is ENE. So I'm going to write ENE at the end. Now the rule is when it comes to your structural diagrams that if you have a double or a triple bond only, that your double or triple bonds have to add the location number. Where is this double bond and triple bond located? All right. Now, in order to do that, you want to look at the left side of your bond and you want to look at the right side of your bond. Okay. So let's start with the left side of our bond. We want to count how many hydrocarbons that it takes us to get to that double bond. So we see that in this case on the left side, it takes us 1, 2, 3. It takes us 3 hydrocarbons to get to this double bond. But then on the right side of it, it takes me 1, 2, 3, 4. It takes me 4 hydrocarbons to get to this double bond. You want to use the location number of the shortest route. So obviously 3 hydrocarbons versus 4 hydrocarbons. 3 is the lesser or the shorter route that it takes in order to get to that double bond. And so I'm going to go ahead and put 3 dash hexane, and that is my answer. Okay. Now I know we went over a lot. Okay. We went over a lot. It takes practice. You have to practice. Don't freak out. Just practice and rewatch this video as many times as you need to in order for you to grasp and catch what you did not understand previously. If there's anything that you would have liked for me to go more in depth with, please leave a comment down below. And I promise you, I will do a video addressing that for you. Now, if you are in my class, you can come to me with the question and I will help assist you one-on-one with the question of the things that you were confused about. I hope this helps. We got work to do, guys. And you'll soon be a master at knowing how to identify hydrocarbons. Okay? In the next video, we will be going over ionic bonds and covalent bonds as well. So please make sure that you are on the lookout for that, and I will see you next time. Bye.
Don't play with it, don't be dishonest. Ay, still not understand.